One of the most overlooked advantages of using SOLIDWORKS, a 3D modeling program, is actually hidden within the 2D environment it has. There are a set of block commands within the Sketch environment that can greatly enhance the user ability to design machines from scratch a lot more easily, like you see these students doing. Most users may not even know about this capability because historically a block is simply a 2D sketch command. With blocks in SOLIDWORKS, you can make a fully functional moving sketch that shows the interaction of components, motions of assemblies, and placements for actuators and motors. Creating and using blocks is easy. When you create a new assembly, you can use the layout option to begin creating blocks and then make a part file from each block, but you do not need to be in the assembly environment to use these commands because they also work in the part environment. First, start a sketch or layout and begin drawing your components. For these blocks, you should still use most of your good practices and fully define each sketch, but it is not necessary because each time you create a block it will break the tie with the origin. Keeping the dimensions and tolerances you want is important. When you use a block, you have the option to save it as a solid block file or SLDBLK. Once you create a block, you can move it around relative to the sketch origin. I usually make all of my blocks first and then put them together using relations. Blocks utilize the same sketch relations that you're familiar with in a normal sketch environment, with the addition of a few mechanical relations only used with blocks that I will showcase at the end. I'm going to use a couple of examples that we use in robotics to design components. I can draw most of the basic assembly within a single block and the moving components around it. I've already created the base of one of our robots as a block, so I can insert that at any time. For the rest of the robot, we will replicate a recent challenge students had to complete and finish a crank rocker device which was powered by a gearbox and stretched spear gun tubing. This device will release a powerful kick and launch the desired projectile across the field. Blocks can be moved and mated in place just like other sketch entities. Blocks use dimensions and relations together to show motion. You can partially define the sketch blocks so that the motions behave in many ways that help engineers define their machines. Pivots, actuator placements, motor locations, ranges of motion, and many more important things can be discovered by using a series of blocks. If you walked up to a SOLIDWORKS user and asked them if there was a way to design an entire assembly from scratch without making all of the parts or an assembly file, most of them will probably say no or that it would not be easy. Here is an actuator design. The pneumatic piston consists of two parts with a collinear relation. The blocks can be edited at any time to change the geometry. How easy is that? You can create an actuator and find the position of both ends of the actuator as well as the range of motion for this assembly. Here is a gear and belt system which can only be accessed when using the sketch blocks. The belt command is on the sketch blocks toolbar and the gear command works with the same selections as a tangent relation. You can see the correct behavior of this system using sketches and determine the length of the belt or find the placement of parts involved. This is just one of the many ways SOLIDWORKS can help students and engineers design and plan their assemblies faster than ever.